In this video, we will learn about lens formula and the linear magnification. So, the lens formula gives the relationship between the object distance, that is u, image distance, that is v, and focal length, that is f. So, it is expressed in the following terms. 1 upon focal length gives 1 upon image distance minus 1 upon object distance. So, this is the formula that you have to learn by heart. Okay. Now, the focal length of a spherical lens depends on its radii of curvature of its two spherical surfaces and the refractive index of the lens material as per the relation 1 upon focal length equals refractive index of lens minus 1, 1 upon R1 minus 1 upon R2. Okay. Now, the lens formula given above in the general relation is valid in all situations for any spherical lenses, convex as well as concave, and for all positions of the object. Of course, we must use appropriate positive, negative sign as per the new Cartesian sign convention while submitting numerical values of u, v, and f. Now, the lens formula involves three terms, which is the object distance u, the image distance v, and focal length f. If values of any two terms are known to us, then we can easily calculate the value of the third term. Now, while substituting the value of known terms, we must put the values with their proper sign in the lens formula. However, no sign is to be assigned to an unknown third term, which is to be calculated. Its proper sign will come by itself from the calculations as per the lens formula. Example. Now, suppose this is your lens and this is your principal axis. Your object is lying over here with u distance and the image of this is formed over here with v distance. Okay. Now, the sign conventions are to be taken from the optical center, that is over here. Now I can say that this side is positive and this side is negative. So while writing the formula 1 upon f, that is 1 upon v minus 1 upon u, so it would be plus v and minus u. Then I can easily get the focal length. Okay. This minus and this minus are two different things. Okay. This is from the sign convention and this is from the formula. Don't mix them up while solving the questions. Now, linear magnification. The relative size of an image of an object formed by a spherical lens depends on the nature of lens, the position of the object in front of the lens. Now, magnification produced by a lens gives the relative extent to which the image of an object is enlarged or diminished with respect to the object size. Now, for a linear object held normal to the principal axis of a spherical lens, like this. This is an object. The linear magnification is expressed as the ratio of the height of the image to the height of the object. Suppose this is the height of the object and this is the height of the image if the image is formed over here. If h be the height of an object and h dash be the height of an image formed by the spherical lens, then the value of linear magnification will be m equals height of image divided by height of object. Okay. Magnification produced by a lens is related to the object distance u and image distance v as per the medium. Magnification is equals to v upon u. Okay. Now we can write that magnification would be equal to image height upon object height, and that is equal to image distance upon object distance. Okay. This is the final formula. Now, usually the linear object is placed normal to the principal axis and above the principal axis. Therefore, height h of an object is taken positive. For virtual erect image of an object, the height of the image, that is h dash, is taken positive and therefore magnification will be positive. For a real inverted image, the height of an image, that is h dash, is taken to be negative. So the magnification is negative for a real image. The linear magnification of a spherical lens may also be expressed as m equals height of image upon height of object, that is distance of image upon distance of object, would be equal to f minus v upon f, that would be equal to f, that would be further equal to f upon u plus f. Okay, I have derived these things using the lens formula, which is 1 by f equals 1 by v minus 1 by u. Okay. Now, as the convex lens may form real as well as virtual images depending upon the position of the object. Hence, magnification of a convex lens may be negative or positive depending on the nature of image. On the other hand, a concave lens forms a virtual image only, so magnification of concave lens is always positive. Now, the magnification value of more than one indicates that relatively enlarged image is formed, and magnification value of lesser than one indicates relatively diminished images formed. Okay, I hope this topic is clear to you. Thank you.